Hello everyone. Today we're going to do a video where we're going to use our radius dresser, and we're going to dress a 1/2 inch radius on the surface grinding wheel, and we're going to come in and we're going to grind the radius on the squareness comparator gauge right here. I currently have that milled out to 3/8, and again these are in kind of prototype design, and so it's kind of evolving as I go. 1/2 inch radius is, I think, going to work out better. I've done that on our unit and some others, and just got a better finger grip on it. And so we're going to do that. But before we get there, we just want to give a big thanks to Jim Phillips. He's been a long time subscriber and viewer. But in his generosity, he sent us this turntable. And he ground the surface up here. I haven't had a chance to really mess with this yet, but I'm itching to really get this thing going. Well, a couple things I got to do is, one, we got the base that this mounts on, and it looks like it's a piece of hot roll. I'm going to clean these sides up over here on the mill, and then I'll regrind the flatness, and I may regrind this. Sides on there so that I can use it on the mill, just right in the Kurt vise. But anyways, this is a nice little turntable, a nice small compact one, and it's even got the divider head and plates. And Jim surface ground the surface on here, and we're going to have to, when I get a chance, cover up this area down here so I don't get any grit in it. But then I'm going to have to grind these high spots right here parallel to that, and then that way I can check, because he's curious how well of a grind job that he's done on that. And so this will be a future project, and you'll see us probably doing the squaring and everything a little bit later in the video. But he sent this a couple months ago, and I just wanted to give him a big thanks and a shout out. We'll use this on a lot of our projects here in the future, so you'll see this unit once we get her all straightened out, fixed up good. You'll see it in use a lot. We're going to go over to the granite table right now, and we're going to show you how to set up that radius dresser. Okay, here is our radius dresser. I used it maybe once already. We'll be using it probably quite often. It's a Yuasa. I hope I pronounced that right. But it's a high quality, high-end radius dresser. We got this on eBay. It was never used in an open box, which we didn't get the box. But anyways, and that's not a big deal because I got it for $275, so there's no complaints here. The thing is nice and smooth, works awesome. And we're going to set our diamond to a 1/4 inch radius. What I wanted, I think I was talking about a 1/2 inch radius on the part. I actually need a 1/4 inch radius, not a 1/2 inch. I was using a 1/2 inch ball nose end mill on some of them, and that's what I'm wanting to reproduce. So anyways, there's a lot of adjustment features in here, and I'm not going to go in detail on this because Stan at Bar Z Industrial, he just recently did a video. He did an awesome job, and he shows you in detail if you're interested on how to set these. So I'm just going to highlight that a little bit. But before we do that, I want to show you a couple of the different diamond tips over here. For what I'm doing, I just need a 1/2 inch or a 1/4 inch radius. It doesn't even have to be that great. So the diamond I'm using is one that I've used already, where it's rounded on the tip a little bit, so it's nice and strong, and I know it's not going to break away, and it's going to do a good job. I bought some of these diamond tips right here. Was it phono tips, I believe? I don't know if I'm pronouncing that right either. But anyhow, they come at a 60-degree angle, and then that diamond has got a very sharp point. And if you try to use a diamond that's coming to a sharp point with a rough grit wheel, you're going to tear that point off right away. And so you're going to, if you take 5/1000ths off your 5/10,000ths off the tip of that diamond, your radius is going to be way out of size. What I found in the past is that when you come up and you got a fine diamond like that, they actually work better with a very fine grit wheel. And then you got to be very careful going in there. So anyhow, we're going to use this coarser diamond for what we're doing. It'll work fine. The unit comes with a standard, which is at the center height of the axes that this spins on. And we already preset the wheels, but I'll just show you. We got this vernier scale on the back. Basically what you do is you wind it over and you want to get it to 180 degrees. And you can line it up right on 0, and if you look at your 60 on both sides, and if the line's hitting, then it's real accurate on the center, or on 180 degrees. So now this diamond is tipped 180 degrees, and what you do is you can loosen this screw, put your diamond down, adjust it, tighten it down, lift it up, pull it all the way so you don't mar up your surface there. And then what that does, it sets this diamond so that where it's touching, if you spin all the way around, it's spinning right on the center line of the axes of this. By doing that, you can come over here and set up quick angles, because now you have this pin right here that slides back and forth in here. And what is, you got to stop on both sides. This one's on a cam so that you can adjust it. And once you get your diamond set up center line with this pin like that, coming out to this one, what will happen is to make setting up radiuses real quick and easy. This one's on a cam so you can adjust it in there, but it does convex and concave radiuses. So what you want to do at that time, because it's all set on center based on this being engaged, what we want to come down and we want to put a 1/4 inch gauge block in here. And then we want to be gentle with it. But we want to get it adjusted so we can feel that. A little bit of drag on that gauge block. Let's see if we can get in there and snug it down. There, and so you can see there's some nice drag on there. So if everything was set real good, we should have a nice 1/4 inch radius, and so you can see that it's going to pivot like so. What we're going to do is we're going to go to the grinder right now. We're going to set up. I already got the wheel roughed in, but I'll show you what I've done, and we'll go over what wheel I'm using, some of the other details, and then we'll set this unit up and actually dress the wheel. This is the Radiac wheel that I'll be using. It's a open structure. They call it a porous way. It's a 46 grit. It's aluminum oxide ceramic mix. It's a H hardness. And this wheel works really good on anything that's, say, over 62 Rockwell. In DC 53, usually the range you harden that in is going to be between 60 and 64. And I found that these wheels work really good on that DC 53, better than others. And being the porous way, you can actually dry grind without generating too much heat if you do real light cuts. So it actually works out pretty good. Now, this is a brand new wheel we're not going to use. This is a wheel that's down to about a 6-inch diameter from use. And when they start getting small, I stop using them because you're dressing them more often. They load up faster. You don't have near the cutting material because you're a couple inches less on your circumference, and so you fool around with them a little bit more. But then they work great when you want to do something like I'm doing right now, dressing radiuses. And before we do the radius, I'm going to show you how I roughed that in. And Kathy's going to have to change angles on the camera with me over here so that I'm not blocking the view. What I'm going to use to rough that wheel, or what I did use to rough that wheel so that I don't have to wear my diamond out. That wheel was square, and if I would start with the radius dresser square, I could rough it out, but I'd have to reset my diamond if I wanted an accurate angle because it would probably be off a little bit. So I believe this is a boride nitrate stick, if I remember correct. I'm not real certain on if I got the name on it right. Don't have time to look it up. But basically this is for hand dressing wheels. And what you want to do is you want to lock your table down, because I always support myself, and it does get a little bit dangerous because your hands will be kind of close to the wheel. Why lock the table down? So that I don't have any accidents. So if you're going to do this, you have to be extremely careful. But basically you can come in there and you can just take it and do it by hand. You can rough out that radius. So you can get it roughed out using one of these. This cuts pretty fast. There's other types of dressing, handheld dressing sticks and stones that you can use that are more aggressive even than this, but this is the most aggressive I have. So I'm going to go ahead and set up the radius tool on here, and we'll dress off that radius. One of the other nice features on this is you can set stops. I'm going just maybe 90 1/4 degrees, about 90 1/4 degrees that way. And the reason I'm doing that, I want to swing past 90. I'm not going to go the full depth of cut. If I wanted to go past the full length of cut, I might go 90 1/2 to 91 degrees. You can lock this down, and by turning the handles over here, you can actually dress an angle. Comes in, locks down, swing your radius, and then you can come up on the other side. And so what you'll have is, you'll have on the side of the wheel, you're going up that direction, coming down, hitting your tangent point, swinging, and on the back side, you're coming up just the opposite way. So that brings everything closer to the center of the wheel, much more, more narrow. So that way, the widest part of the wheel will be what your radius is. Because I'm not going full depth, that's not necessary. So I just went like 90 1/4 degrees. It does have the stop system, so if I pull it out, I can actually go past the 90 1/2 degrees either way. But what I'm going to do is I'm going to pull it right up to my stop, lock it down, and I need to have a reference on the side of the wheel. This wheel is thicker than a 1/2 inch, I'm pretty certain. So I'm just going to hit the front side here for a reference, which I've already done, but we'll do it again. So I just want to come until I touch it in the Y. And what I'll do is I'll wind in a few thousandths. I'll set my digital 0. I didn't hit yet. There we go. Yeah, just. So now I have a nice reference point where I'm at this way. I'll set my digital 0 there in the Y-axis. Spin it around this way. Set the stop, lock it in. And so I can do the same thing. And I can tell by the digital, by dressing it this way, that wheel is about 530 thousandths thick. But right now, I got my digital set. All I have to do is wind over half of what I had. at 15 thousandths, so I'll wind 7.5. Set digital there, or the digital to 0. So now I'm halfway. When I put this radius, I should be right on the center of the wheel. Now I'm going to come up in the Z. So you can see that we're already touching on the radius, so set Z on 0. And what we want to do is we want to come up until that's hitting the wheel all the way around. I'll go a couple thou at a time. There, now it looks like we're all the way around on it. I'll just go a little bit more. Yeah, I can hear it all the way around now. Here'll be the last cut. Pull this off. I'll just take a popsicle stick. And that way you can see that we got a real nice radius on there. What I'm going to do now, I'm going to set our part up. Getting it ready, getting it kind of centered so that we can grind that radius, and we'll be back in a minute or two. What I did is I got this mounted in my V-block. I got it clamped in over here. That way it'll hold it up at a 45-degree angle. And what I did is I touched the wheel so that it hit this edge and this edge, so I centered it, and then actually looked at it, eyeballed it. I'm going to just plunge straight down on that a little bit at a time. Made a slight adjustment. Okay, we have it all cleaned up, and with a radius this big you have a lot of surface hitting that wheel, so it's really hard to get a really good finish. And so what I do is I'll let it spark out a little bit, which I've already done, and then what I'll do is I'll just lightly come in there and go real slow. But I don't want to do this in heavy cut. You can just barely hear it cutting right now. You're not even seeing sparks, because if I done this on a heavier cut, it would generate a lot of heat in there going that slow. But by going slow like this with a couple passes, you can get a really nice finish. Now I can get a better finish if I want to redress the wheel and just come in there with a freshly dressed wheel as well. But for this, it's finger grooves. That finish is going to be plenty good enough. And what I'll do is I'll take this off and we'll throw it on the granite so that Kathy can get some close-ups and you can see how nice the finish and the radius, everything is here. Well, here you have it. Right here is a 1/4 inch radius, and the reason I opened that up, it works, it feels good in the hand. So this side's a 1/4 inch radius. When I machine these, I use the 3/8 ball nose, so a 3/16 radius, and you can see the difference. And the finish on there, like I say, is really nice. It's non-functional other than a finger groove. I could get the finish even nicer by redressing the wheel, but it's not going to be such a great difference that it would be really worth it. So when I get a bunch of these set up in the future, I'll be running with a 1/2 inch ball nose end mill, so I won't have as much hogging out and cleaning them out, and they'll work pretty nice. So anyways, I got 2 of these. In fact, one of these will go to Jim Phillips, the individual we talked about that gave us a rotary table at the beginning of the video. So we're almost done with these 2. And Stephen Brown will be getting another one of them as well. Okay, the next video that we're planning on doing is we're going to take this wheel. We got this from Continental Diamond Tool. It's a CBN wheel. It's 150 grit with a 75 concentration. It has an aluminum hub on there, and it's got a 1/4 inch thickness of a resin bound CBN. And what we're going to do is we're going to true this up. I got some diamond tools that are designed specifically for dressing this up like you would do a regular wheel. We'll dress that up, we'll dress the sides, and then what we're going to use this for is for side wheeling on the inside slots of these. You're using the stone wheel with this DC53 because it is so hard. It's hard to get away from burning and heat. The CBN wheel will cut so free. I won't have any of that. The other nice thing is it doesn't break away hardly at all. So for holding sizes, especially doing slotting, you can't beat this. Another nice feature of the CBN wheels when you use them on the surface grinder is when I use this along with my Suburban rotary tool that we just had for doing OD work. The CBN, if you get a pin in there and you got multiple steps on there for holding the shoulders, holding the diameters, you can't beat this because it doesn't hardly break down at all. Very accurate, very good finish. And so you'll probably be seeing this wheel in use quite often as well in future videos. Well, that'll be it for today. We'll see you next time.